All right, welcome back to the final installment of the Ohm's Law video series. So what we're going to do in this video is combination circuits. And the coolest thing about combination circuits are you guys already know how to do all the math that's involved. We're really just using stuff that you know, adding it all together. So let's go ahead and just draw up a combination circuit really fast. We've got our power source, AC for this one, and then we're going to come in and we're going to have two legs that drop down, and we're going to kind of start a parallel circuit at this point. And I'm just going to go ahead and draw in a resistor. All right, another resistor. Remember, these ones are in parallel, so those are going to come in together, and then we're going to have a resistor in series before we come back. So I'm just going to kind of draw some lines. All right, so as you can see, these two right here are in parallel, while this one's in series. So to figure out the answer to these questions, what we need to do is we need to take and use our special formula for doing parallel circuits, apply it to these two, and then we're going to add this one in. So let's say that we had 10 ohms of resistance here, and we'll say 10 ohms of resistance. Actually, let's do a different number here. Let's do like 8 ohms of resistance here. And then we'll say 20 ohms of resistance on this one. All right? So what we're going to do is I'm going to go and move over here on the whiteboard. We're going to apply this to our formula, and then we're going to add the 20 ohms here to figure out how much resistance we have in this circuit. So I'm just going to go ahead and quickly throw these in to this formula. So remember, we got our R1 is going to be 10, and we plus our R2, which is going to be 8 for this one. So I'm going to grab my calculator. So the 10 is going to become, we can just go ahead and erase it. It's going to become 0.1, and the 8 will become 1 divided by 8 will equal 0.125. Oops, forgot to put the 1 there. So we're just going to add those together, which will equal 2.25. So we can go ahead and just erase all this, and we're just going to write 0.225. So it'll be 1 divided by 0.225. So we'll do that one on the calculator because it's a little bit more complicated. 1 divided by 0.225 will equal 4.4. We'll just do 4.4, okay? So like I said, we're going to only take everything to the second decimal, and this is how many ohms we have in our parallel circuit. Now if we go back to our circuit, we're going to see that we have another resistor, but it's in series. So we're just going to take that other resistor and we're going to add it to this 4.44 ohms of resistance. So let's take a look at that really quick. So the two of these combined are what's going to equal that 4.44 ohms right up here, and then we're going to have to add this 20 ohms right here. So the answer to this problem for our total resistance, we're just going to mark that as T, will equal 24.44 ohms of resistance. So it really isn't that bad to figure out one of these circuits. They do come and they look totally different. There's going to be multiple circuits that you're going to have to work with. I'm going to quickly draw up a few of them for you guys, just so you can see some different things. So forgive some of my drawing here, it's a little bit crooked, but you're going to work with one of these circuits in the math section, and you're going to notice that the ground is going to a chassis ground or some sort of ground that will be linked on all three of these legs. So this changes nothing. Pretty much what it's saying is that on this circuit, these would be connected to the ground or the chassis ground or something like that. This isn't the exact symbol for a chassis ground, but it is very common that you'll see this symbol meaning to go back to a chassis or something like that. But otherwise, you're just going to take these three resistors in parallel, you're going to put them into the formula, you're going to figure out what that total resistance for these ones are, and then you're going to add it to this resistor up here. So this one's very common. Otherwise, this one and that first one I did, and then also maybe the resistor or combination circuit that you've seen in the actual demo for lab, I think it's like 2-8. That one, you might see that one too, but in reality, they're the same thing. Okay, so if you guys got any questions or if there's anything else I can go over, please let me know. Just try to move through these questions as best you can.